Okay, everyone, let's continue looking at Module 26211-23, Control Systems and Fundamental Concepts in the NCCER 11th edition. This will be Section 2.00, Relays. While contactors are typically used in high current applications, relays are used in control circuits to switch relatively low current loads. Relays often contain poles with multiple contacts. These traditional magnetic relays are still very common. Solid-state relays are growing in popularity. Some relays are designed to provide circuit and equipment protection. Control relays vary widely in their characteristics and are used in many different applications, including current amplification, voltage amplification, switch function multiplication, and operating sequencing. Here's an example of current amplification and voltage amplification. An example of switch function multiplication and operation sequencing. Timing relays. Timing relays have contacts that are repositioned after a specific time interval. An on delay refers to a delay in the contact movement after the relay coil is energized. An off delay refers to a delay in contact movement after the relay coil is de-energized. Timing relays may be driven by a clock-type mechanism, but solid-state timing devices are also very common. Solid-state relays are electronic switching devices. Some advantages of a solid-state relay include no moving parts, resistant to shock and vibration, well sealed against dirt and moisture. Control input voltage can be isolated from the relay control circuit. Typical solid-state relay control circuits include power transistors for DC loads, triac-controlled AC relays, and reed-controlled AC relays. Overload relays are used to protect motors and their associated circuits from prolonged overloads. Bimetallic overload relays rely on a heater element and a bimetallic strip to actuate the overload relay contacts. Under an overload condition, current increases, generating heat and causing the overload relay to open. In a manual starter, overheated thermal elements trip a mechanical latch, forcing the contacts to open. In a magnetic starter, the thermal elements open a set of contacts in series with the starter coil. Fuses versus overload relays. Fuses are best suited to protect against short circuits and grounded windings. Motor inrush current makes it difficult to select single element fuses that offer meaningful protection. Fuse size solely on FLA will blow every time the motor starts. Fuses large enough to handle inrush current offer little protection during normal operation. Overload relays are able to hold the inrush current but open if movement is sustained. Magnetic overload relays react only to excessive current. Thermal overload relays react to a rise in temperature. Melting alloy relays require a cool-off period before the motor can be restarted. Bimetallic overload relays can be field adjusted and sometimes reset automatically. Electronic overload relays offer greater versatility. Overload relay selection. When selecting thermal overload relays, the following factors should be considered: motor full load current, type of motor, and the difference in ambient temperature between the motor and a controller. Troubleshooting relays. Successful operation of a relay depends on proper interaction between its solenoid coil and its mechanical components. Common causes of relay failure include excessive fluctuation in coil supply, voltage, internal binding, damaged contacts, and excessive current flow through the contacts. Troubleshooting charts can be used to help identify and correct relay problems. And some trade terms for you to read over and become familiar with. And some review questions for this section. A single pole push-button contact can be used to control multiple loads using a single pole relay, a current amplifier relay, a voltage amplifier relay, or a multiple pole relay. And that would be a multiple pole relay. A type of relay controlled by a magnetic field is a opto-isolated relay, a power transistor, a triac, or a reed relay. And that would be a reed relay. The type of overload device that requires a cooling off period before it can be reset is a time delay fuse, a dual element fuse, a melting alloy relay, or a fusible link. That would be a melting alloy relay. The solenoid coil of a relay is typically designed to work properly at 80 to 100% of the rated voltage, 90 to 100%, 95 to 105%, or 100%. That's going to be 80 to 100% of the rated voltage. All right, everyone, that was it for that section. The next section will be 3.00, low voltage control systems, and I'll see you over there.